So in our last lecture, we talked about cellular respiration, what cellular respiration is, how it's taking glucose in the cell and converting it into ATP energy, because glucose is not a usable form of energy, but ATP is. We know that ATP gives us all our energy, and that in plants, photosynthesis creates the glucose, but then we use that glucose to create ATP. We should know the equation. We should know what happens in the cytoplasm and the mitochondria. If you're prokaryotic, you should know that it works in the cytoplasm because they don't have mitochondria, while the rest of us want to get it to the mitochondria because it gives more energy if we get it to the mitochondria. So we're going to talk about the two different types of respiration today. First, aerobic respiration, which is respiration with oxygen present. So you're going to see oxygen in that equation because oxygen is present and being used in this equation. Aerobic respiration occurs in the mitochondria, so anytime cellular respiration is happening in the mitochondria, it is aerobic. It produces a lot of energy. So it produces about 32 to 38 ATP. I would write that down in your notes packet. 32 to 38 ATP for aerobic respiration. So it produces a lot. It happens in animals, plants, fungi, and protists. Basically, anything that has a mitochondria and oxygen present is going to happen in the mitochondria, and it's going to be aerobic with oxygen. We prefer for it to be aerobic if we have those mitochondria because aerobic respiration gives us 32 to 38 ATP. So it gives us a lot of ATP. We want to be efficient. We want to create as much as possible. But sometimes that is not always possible, and that's why there's anaerobic respiration. And this is where there's no oxygen present. This happens in the cytoplasm, and it does not produce much energy. So it only produces about 2 ATP instead of 32 to 38, right? 2 is not as much as that. So once again, we prefer the aerobic, but anaerobic happens when we don't have oxygen present, we don't have enough time to get it to our mitochondria because we need it so quickly, or you don't even have a mitochondria, like prokaryotic cells. So you'll notice that prokaryotic cells actually only go through anaerobic respiration. They only can do it in their cytoplasm because they do not have a mitochondria, while aerobic respiration happens specifically in that mitochondria. And now we're going to talk about a couple of different types of anaerobic respiration. Another word for anaerobic respiration is fermentation. We'll use this word a lot this unit. Fermentation is respiration not requiring oxygen, so anaerobic respiration. During fermentation, glucose is turned into lactic acid or alcohol. These are byproducts that it's going to create instead of water because you're not putting oxygen in, and so you're not going to be able to bring water out. And instead, you're bringing these two things instead, lactic acid or alcohol, depending on the type of fermentation it is. Once again, it does not produce very much energy, only about 2 ATP, but it is necessary because you still need ATP in your cells. So if you don't have that oxygen present or you don't have that mitochondria, you still need to go through anaerobic respiration. There are two types we're going to talk about. First is alcoholic, and then the second is lactic acid fermentation. Alcoholic fermentation takes that glucose. You'll notice that oxygen is not here on this side of the equation, like in regular cellular respiration, because it's anaerobic. No oxygen is present. So you're just going to take that glucose and turn it into ethyl alcohol, carbon dioxide, and 2 ATP. Ethyl alcohol is the byproduct that you're creating instead of that water. This happens in organisms like yeast and bacteria, and we actually take advantage of this in a couple of industries. First, we take advantage of it in the baking industry. When we make bread, we put yeast in that bread. Well, why are we putting yeast in that bread? The yeast actually produces the ethyl alcohol and carbon dioxide, which allows the bread to rise. So when you're putting the yeast in the dough, you just leave it for a bit, and you'll notice that the dough will start to rise from the carbon dioxide production. Now, when you bake the bread, the alcohol is going to come out of it, so you're not going to end up having alcoholic bread, but the carbon dioxide will still be there to where it'll make it fluffy instead of just a hard rock. We also take advantage of this process in brewing and winemaking. The whole goal for people who brew beer or make wine is to create alcohol, right? You either want to create it from the hops that you have, or you want to create it from the grapes that you have. And so what they'll do is they'll put yeast or bacteria in the wheat or the hops or in the grapes and let it sit and ferment. See, fermentation. They allow it to ferment. And because of that, it's going to carbonate it. So some wines and beers will have carbonation if they allow the carbonation to stay and keep it in a closed container. And it's going to have alcohol present. And so this is very important in a couple of our industries that these organisms go through. The second one we're going to talk about is lactic acid fermentation. When you go and work out, your muscles are going to have a high demand of energy. But you don't always have enough time to supply enough oxygen to those cells that need the oxygen at that time. And so you're not going to go and create that ATP in your mitochondria because there's not enough time to take it there and you don't have enough oxygen to create it there. And so it's actually going to happen in the cytoplasm. And because of this, it's going to create a byproduct as well. So here, once again, you have glucose. No oxygen is present here. And then it creates lactic acid, carbon dioxide, and 2 ATP. You're still producing carbon dioxide. You know that because you're breathing pretty heavy trying to get all the carbon dioxide out. But then you're also creating this thing called lactic acid. Lactic acid, when it builds up in those muscles, it's going to give you that burning, painful sensation. So whenever you're doing a really hard workout, or you have a big game or things like that where you're working those muscles super hard and you end up having to go through lactic acid fermentation, your muscles the next day are going to be super stiff and sore. And so your coach then tells you, hey, let's roll out those muscles to help move that lactic acid out of those cells and back into your bloodstream so you can get rid of it. And so that's why you end up having that burning, painful sensation because you're going through fermentation instead of aerobic cellular respiration. This only happens in animals because animals are the only ones who have muscles, right? If it's happening only in our muscle cells, it can only happen in animals. So once again, lactic acid fermentation happens in the cytoplasm, creates lactic acid, which makes our muscles super sore, and 2 ATP. Alcoholic fermentation happens in yeast and bacteria, creates that ethanol or ethyl alcohol as a byproduct, and 2 ATP. And then we always have the aerobic respiration, which we talked about yesterday, where you have the glucose, oxygen, creating carbon dioxide, water, and ATP. And this one creates so much more energy, and that's why we prefer the aerobic respiration over the anaerobic.